Hey everyone, let's check out something familiar to us. So what we looked at last time with the derivation of an immediate annuity, we saw that with actually 6 time periods that we would be getting, six $1 payments, and we found out what the formula was, but that was when each $1 payment was made at the end of the year. What happens if they're made at the start of the year? For example, in this case, we're going to get $1 at time 0, so right now, and then $1 at the end of the year, and so on. So we're still getting 6 payments, but in fact it seems like it's going over 5 years. That includes the first year. So how do we find out the present value of something like that? So again, this one doesn't have to be discounted because we've already got it today. Plus, this one will be discounted by a factor of v, and again, v squared, v cubed, v4, and v5, again where v is equal to 1 on 1 plus I. So this is also a sum of a geometric series, except it starts off with 1 instead of starting off with v. So we can call this equation 1, and we can also multiply it by v, and so we'll get v times the present value is then going to be, we multiply everything inside of that first equation by v. So let's just quickly jot that down. Alright, as you can see, and that'll be now equation 2. So let's do what we did before, where these are both equal, so let's subtract one from the other and see what sort of ratio comes out in the end. So let's do 1 minus equation number 2. It works out if you do it the other way, it just means you'll probably have to times everything by -1 to get the answer that you're familiar with. So we're going to write the present value minus v, sorry there's no times there, that's present value, and that's then equal to, of course, we've got 1 plus v squared plus v cubed, and we're going to then minus, and I'll just minus it on top of each other, so minus v squared, v cubed, v4, v5, and then there's v6, and as of course we can see we can start cancelling out these similar ones. So what we're left with is a 1 minus v to the 6, which is very similar to what we had last time, but there'll be a slight difference because before we took out the factor v, but here there's nothing to pull out. So let's still write that down as we take out the present value from this first bit. 1 minus v is equal to that. Now let's find that the present value is equal to 1 minus v to the 6 on 1 minus v. Now this bit over here we can leave it the way it is, or we can just say that 1 minus v is equal to d, which is equal to I on 1 plus I. And just to make sure that that makes sense, 1 plus I on 1 plus I minus 1 divided by 1 plus I, they cancel out, equals to I on 1 plus I. So we'll just say that the then present value, or in fact, I don't want to write it like that, I'm going to write it differently. I'll first just write down what it becomes, which is 1 minus v to the 6 on d, and then say that this is equal to something called a double dot 6, an annuity due, where each payment is paid at the start of the period, and this is n, 6 being n, 1 minus v to the 6 on d. Thank you very much for watching, and now we're going to actually start looking at how we can do an increasing annuity, how we derive that formula.